models are more precisely wrong. I need some light. The spherical shell, the Earth is, the atmosphere is not spherical shell, nor is it smooth. The magnetic field warps, wrinkles, and tilts the sky. The atmosphere reflection is not level. It could be tilted as much as 60 degrees. And it might be an advantage if you don't happen to have a perfect antenna. Spencer's going to come up and help me do show and tell. Look at Spencer. There you go, Spencer.
Over here, Spencer. Sit down, Spence.
Hang on. Lost my microphone again. What were your instructions, Spencer?
Be a fool and hold the ball.
Well, that's close. I said, hold the ball and look stupid. Okay. Hold it with both hands. Anyway, this is my prop. I bought a Walmart yesterday for $1. I'll be glad to sell it to somebody for like 50 if you want. Anyway, here's my poor representative. My wife doesn't know I took her salad bowl, but this is the ionosphere. And what people think of that, it looks like this, but it does not. It looks like this for a little while, and then it looks like this, and then it looks like this, and it looks like this, and it looks like this, and it's all over the place. And it is not a round thing, the round circumference of the Earth. Just like we were talking about the Aurora Borealis, it's moving and curving and shaping and stuff like that. And so if you're over here and you're trying to work over here, you know, you hope it looks like this, so it'll be reciprocal, but not necessarily because it's like this. You follow me? You just cannot believe what's going on. All these propagation models will show you this is going to be reciprocal and that's what it's going to look like, but it doesn't happen. And it changes a lot. Anybody notice this? For sure. Thanks. Give Spencer a hand. He did a good job. He can cut the lights. Okay. There's an old axiom in ham radio, which is, if you can't hear them, you can't work them. I know a guy one time that was so desperate to get this DX entity, as soon as he saw him spotted on the spotting cluster, he started calling him. And the guy asked him, can you hear him? He said, no. He said, how do you know when you're working? Well, if you can't hear them, you can't work them, obviously. And they're not going to log, even if they log you, because they heard you, it's not going to do you any good, because you didn't log them, so you can't match up with QSL card, etc. But reality is, just because you can hear them, doesn't mean you can work them. And it doesn't mean they can hear you. Because you may have one-way propagation. In other words, their signal is going over there, coming into you, your signal is going there, which isn't doing you any good at all. I worked a lot of, I've got a Yagi, a directional Yagi. I pointed towards the northeast, and I'm working Europe or Pennsylvania or New York or Connecticut or whatever in some of these United States contests. And Texas comes back. Now, how's that possible? They're off the side of my antenna, right in the middle of my nose. There's no signal off my Yagi going to Texas. I'm working Texas. How's that possible? It's either going around the other way, or instead of the signal going there, it may be going up here and then back down here. It may be reflecting off an angle back into me. So, just because all models say this is what's gonna happen. Just because it makes sense this is what's gonna happen, doesn't necessarily mean that's what's gonna happen. So, while all we can do is predict, what really matters is get on the air and work. It also might be beneficial for you to have multiple types of antennas like we just talked about yesterday.
Yeah, no, what I was gonna say is everything you're talking about is a study in statistics, statistical analysis. You know what they say, there's lies, there's damn lies in statistics.
Exactly. Okay, here's another software program, VOA CAP. This shows you, off to the right there, shows you in colors the percent of your, I gotta give it the last one. Radio coverage prediction on the HF bands and where it's likely to have the highest percentage of propagation. Okay. Another good software program, VOA CAP. Here's one of the charts I talked about. Now this is an interesting chart, and I look at it occasionally. A friend of mine looks at it daily, religiously. This is really important because I took this, when I took this picture, a couple of days ago, what's today? Well, yesterday, I did this yesterday. This is really, really low on the K index, which is good. But what we've got here, we've got from May 8th through May 10th. So we've got 3 days of universal time is showing us the K index, which is good. And it's all in the green, which is good. But sometimes you'll have, whoops. Sometimes you'll have green, 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 popping into yellow, little green, sometimes popping into red. And that's kind of telling you what's been going on these 3-hour averages over the last 3 days. And this is somewhat of a predictor of what's going on. It's kind of like, you know, the stock market. If you see it going down, probably going to be good for a while. If you see it going up, you might have trouble. Okay? So it's a good little chart. Here's another set of charts that are on one of those 2 websites I gave you. And it shows you the X-ray flux and the 3-day flux, and there's more graphs. This is as you start to get into propagation prediction programs and start wanting to get a little more detail, a little more accurate. Everything helps. You know, the more you learn, the more it helps. Okay. So what does all this mean for you? When is the best time to operate? Anytime. How far can I go? Do I need a huge tower on a Yagi? Should I get an amp? The important thing is get on the air. Absolutely get on the air.